Good morning, everyone. Thank you for coming to this talk on the last day of build. This is a Windows Phone multitasking session. Just FYI, in case you forgot, if you didn't see the word phone and you thought this was about Windows multitasking, this is about Windows Phone multitasking. I'm actually quite surprised to see this many people here, this being a Windows conference. Quick show of hands, how many people were interested in Windows Phone before they came to build? Oh, all of you. OK, well, pretty much all of you. That's good to know. But we think that what's happening with Windows is going to drive a lot of interest in Windows Phone because the UI is the same, the application model is very similar, and so on. So before I get started, please silence your cell phones if you have them on right now. And I'll take questions after the talk. There's microphones here. So if you have very, very burning desires, raise your hand and I'll see if I can take it. But I'd like to take them all at the end, please. So that said, my name is Peter Tor. I'm a program manager on the application platform team at Windows Phone. And I've been on the team for a couple of years. Before that, I did HDDVD. Everyone remember HDDVD? And before that, I did security, and before that, I was on Visual Studio. And I was actually the program manager for JScript 10 years ago. And now JavaScript's made this big comeback, which is quite good for me to see. It kind of went down for a while, and now it's come back up again. So that's interesting how things change. So we're going to talk about a bunch of different things today, but there are three takeaways I want you to have, because as a presenter, I can only remember three things, so I can't have four, I can only have three. The first one is that there's a broad set of multitasking features in Windows Phone. Not just one or two, but there's actually quite a broad set. And this is Windows Phone Mango. I'm talking about the release of Windows Phone that's coming out later this year. The second thing is that with Windows Phone, we do a lot of work to balance the user experience, so the applications and games and so on that the user uses with the phone, with what we call phone health. And to us, phone health means things like good battery life, not using too much bandwidth, always be responsive, and so on. And the last thing is that Windows Phone uses a familiar .NET programming model. So if you know C#, and you know XAML, you know how to write a Windows Phone app. I won't be talking about any XAML today. I'm only going to talk about some .NET code to deal with multitasking. So I'm going to assume you know XAML, and I'm not going to talk about GUI design and all that kind of stuff. So with that intro, I'm going to start with a block diagram of multitasking in Windows Phone. And it starts with built-in services in the phone itself. So Windows Phone Mango adds some new services to the phone that do things on your behalf to do with multitasking. We have an alarms and reminders service. We'll look at that. And we have a background transfer service. We'll look at that as well today. But now, Windows Phone can't do everything, right? Sometimes we actually need developer code to do cool stuff. So there are third-party services that you can write that run code in the background as well. We'll talk about background audio, and we'll talk about generic background periodic execution as well. And kind of across all of this, there's also this notion of fast app switching. So just like you've seen with Windows, desktop Windows 8, and they do fast app switching and resuming, we do the same thing in Windows Phone Mango. So we'll see fast app switching. And underlying all of this, to keep that great phone health, is a lot of resource management in the OS. So we've done a lot of work to manage the CPU, to manage memory, to manage network, etc., to make the phone experience great while maintaining phone health. And this is kind of a diagram we like to show the harmony of health and UX, right? It's a balance between the two. So on the UX side, some of the things that we've heard about Windows Phone and some of the things that we believe about it are that it's delightful and responsive. Now, Windows 8 is saying fast and fluid. We say delightful and responsive, but it means the same thing, right? When you're using the phone, there's got great animations. It's always responsive to your touch. It doesn't lag, right? That's delightful and responsive. There's this idea that a user would never regret installing an application. So if you go to the store and you buy an app and you don't like it, you can uninstall it, and that's it. It hasn't made any permanent changes to your phone. It hasn't stolen all your private data. It hasn't corrupted other applications or the operating system itself, right? So the UX of the phone is one that you can trust. If I install an app and I don't like it, I can uninstall it and it's gone. And finally, in Windows Phone, we have this idea of integrated experiences. So desktop Windows has talked about contracts, like they have the search contract and the share contract and so on. In Windows Phone, we have things like hub extensions. So if you have a media app, it can appear in our music and video hub. If you have a photo app, it can appear in our photo hub. And with our new App Connect, if someone does a search in Bing and we know an application that's related to that search, we service applications there too. So we have these things that make the user experience of Windows Phone really, really great. And on the other side, on the health side of things, there's a bunch of things we do too. So the operating system naturally has to be very aware of the battery, right? It's a small device, small battery, but you want it to last all day or even longer. So we do a lot of work to make sure that we're not running down your battery so that when you go home at the end of the day, there's still time to make phone calls, there's still time to browse the web, play games, etc. We also want to be very network aware, and there's two reasons why we want to be network aware. The first is that a lot of people pay for data, right? So if your phone is constantly downloading a lot of data in the background, you can end up with a big bill at the end of the month, what we call bill shock. We don't want that to happen. But the other thing around networking is that the 3G radio on a phone is one of the most expensive in terms of power usage. So kind of tying back into the being battery friendly, we don't want the radio on all the time, or to be going on and off, on and off, on and off all the time, because that drains the battery really, really fast. So we want to coalesce various network activities around the same time so we can kind of piggyback on the radio being up. And then finally, things around performance and reliability and so on. We have a bunch of hardened services in the OS that we do tons and tons of testing on to make sure that they're reliable, they don't crash, they don't use too much bandwidth, etc. So we do a bunch of work on the phone to build these services so that you don't have to. So how do we deal with these things when multitasking comes in? Because in Windows Phone 7, we didn't have third-party multitasking, but we had all those benefits of a great UX and battery-friendly and so on. Now in Mango, we're adding multitasking. So how do we keep the same promise of great UX with great phone health? Well, there's a bunch of things. The first is we've added some new operating system services. So alarms and reminders and background transfer that we just talked about a little bit. And they're the hardened services that we write and we test. But they can't do all the work. I mentioned there was background audio that you can do, and there's background processing you can do. And so from time to time, we need to ask third-party developer code to do work. But rather than the olden days of, say, Windows Mobile or Windows prior to Windows 8, we don't have applications just sitting in the background, spinning CPU and doing whatever they want to, on the off chance that there might be work to do. What we do in Windows Phone is only ask you to do processing when we know you need to do it. And then when you finish doing it, we can turn off your code so it's not using battery, it's not using network. So we do processing on demand, and we really make sure that you're not wasting resources on the phone. The next thing we do, sorry if this doesn't appear very well, it says balance foreground and background. Now what this means is we can't just allocate all of our CPU to the foreground, because then that would starve the background. And we can't allocate too much CPU to the background, because then that would starve the foreground. So we've done a ton of work in Windows Phone Mango around thread priorities and thread quantum and so on, to make sure that when we're running a foreground experience and a background experience, they both get allocated a suitable amount of CPU and a suitable amount of memory, so they can both get their jobs done. And often we think about protecting the foreground experience because, for example, if you're playing a game, you don't want some background processing to make your game stutter. But background is also important too, right? We can't starve the background because if you're listening to music, for example, you don't want the media to stutter because the background couldn't get CPU cycles, right? So this is where we've spent a ton of time tuning the system around balancing these two. So the next thing we do is we try and align these things with system and user activity. And the example I'll give here is the network again. So I said that the radio is one of the most expensive, power-hungry things on the phone. And we don't want to bring up the radio, do some work, shut the radio down, and then a minute later bring it up again to do more work. So what we will do is we will try and align background processing with things like email sync or the user's activity of the phone, so that when the radio is already up, we can piggyback on that and not take the cost of firing up the radio over and over again, wasting your battery. And then finally, we do all this and we monitor resources as well. So we don't run your code unless we need to. We balance the foreground and the background. We do these things, but also we monitor things. We put background code in a small box, small amount of CPU, small amount of memory, and if it violates those things, we terminate it. Right? So we keep the system healthy by doing this. I'm going to start now, so that's kind of the underpinnings of multitasking. I'm going to start with a demo of fast application switching, which technically isn't multitasking, but from a user point of view can be seen as multitasking. So I switch over here, and I have my Windows Phone Mango here. Whoops. And what I have here is I have Engadget, right, the Engadget app. It's a Windows Phone 7 app, not a Mango app, but I'm using it. And I decide I want to do something else. So I click Start, scroll down, and here I have a simple Twitter app that I've written. If you've seen the demos I've done recently on Channel 9, this is the app I was using there. So I can use my app, and I can scroll up and down. I can hit Start, let's go to, say, settings. I can scroll up and down here. And let's say I want to get back to that Twitter app. I tap and hold the back button. Up comes our task switching UI. And watch how fast this happens. I click on my tweet app, and it's instantly usable. Right? Instant resume. But while it was in the background, it wasn't using resources. We'd suspended it. And if you look here, Engadget is also in the backstack. Now, it wasn't a Mango app, so when I tap on it, it disappears and it reloads again. And it takes a while to get useful, but it's there. It's still in the backstack. So we do support Windows Phone 7 apps in our multitasking UI. It's just that they don't restart instantly. There's a little bit of a lag, and we'll talk about that next. So that's a very quick demo of multitasking on a Windows Phone, Mango. So what does it take to support multitasking on Windows Phone? Well, there's a bunch of things the operating system does. You've seen that I was the one that was in control of what app was in the foreground. Right? I launched apps from start, I switched to them with the task switcher, and I was the one that was in control of who was in the foreground, and therefore who had the CPU. Right? Everyone that wasn't in the foreground didn't get CPU. The way we do that is that we suspend threads in the background. So if you went to Ben's talk about how Windows does suspending a couple of days ago, we do pretty much the same thing. When your app goes from the foreground to the background, we give you a couple of seconds to save out state, then we suspend you. No activity until you come back to the foreground. And then as you've seen, the OS is compatible with 7.0 apps in that they're in the switcher and you can switch to them, but they don't resume instantly. So if you have a 7.0 app, how do you fix that? Well, you fire up Visual Studio, you open your project, you upgrade it to Mango, right-click, upgrade to Mango, recompile it, and then make sure it works. Now, if your app is written correctly with our pause and resume contract, our activated-deactivated contract, it will just work, and you'll get instant resume. You might find out that you have some bugs in the way that you resume without being terminated. You fix them, and you're pretty much done. And then the next 2 points here are about further optimizing your application. So in Windows Phone 7, if your app went to the background, most of the time it got terminated. Right? We killed the process, and that's how we stopped it using resources. So when we brought it back up again, your application had to then reacquire objects, reacquire data, refresh the screen, etc. But in Mango, if you've only been suspended and not terminated, you don't need to do that. So what these last 2 points here are saying is that you can now optimize your code. So when you come back in Mango, if your process wasn't terminated, you don't need to refresh. You don't need to do that reloading. You're just instantly usable like that Twitter application was. So I'll talk a little bit about application lifecycle and how that works with the Twitter app you saw and with the Engadget app and why they're slightly different. And I won't spend long here because this has been talked about at Mix and so on for a couple of years. So imagine your application is running, users using it. And they switch away by clicking the start button, for example. Now your application gets deactivated. It gets a few seconds to save state. And if it's a Mango app, it now becomes dormant. Right? We freeze the threads, but we keep it in memory. Then if the user uses the back button or the multitasking UI and switches back to your application, you become activated, and you're now running again. So that's what happens in a Mango app by default. But if you are a Windows Phone 7 app that hasn't been upgraded, or the system is low on memory, what it will do is it will tombstone your application, right? Which means essentially we terminate the process, but we remember the backstack. We remember the state of the pages in your application. And this is where the reloading only if needed comes in. So if you came back from dormant to activated, you don't need to do anything. If you came from tombstoned to activated, then you need to refresh your state, reload your data because your process has been recreated. So that's it for fast app switching, and now I'm going to switch to a demo of alarms and reminders, which is our first demonstration of multitasking services in Windows Phone. So we're going to run this app, this demo app that I have here. And what I'm going to do is I have a couple of text boxes here. I'm just going to type in some text that will represent the reminder title and content that will show, and it'll fire a reminder that will then launch you back into the app. I apologize for the glitching in the software keyboard. That's just a problem that happens when we do the USB out. It doesn't look like that on the phone, I promise. So I'm going to look at my title and just call this foo. And my content will be hello from build. And now I'm just going to hit remind me. I'm going to quit the app back to the start menu. And then in a few seconds, we're going to see a reminder pop up, and it's going to say foo, hello from Build. And I can click on that, and I can launch back into the app. And I'll show you the code in a second. The code's very simple. So here's my reminder. It looks just like the normal reminders. If you have a Windows Phone, you've seen this before. I can change my snooze time from 5 minutes to 10 minutes, etc. I could snooze the reminder. I could dismiss the reminder. But what I could also do is I can just click on the text. And that launches the application. And you'll see it passed in the value hello from Build, which is what I had in that reminder. And that trick of tapping on reminder text works in the calendar too. A lot of people don't know about it. But if any reminder pops up, as long as the phone isn't locked, if you tap on the text, it'll launch that particular thing. Right. So let's take a look at the code for how this worked. Very, very simple code, actually. So, like I said, I'm not going to talk about XAML or the UI or anything like that. I'm just going to talk about the code. So when I wanted to create the reminder, right, I had those two text boxes, I clicked the button. I first create a new object called reminder, and I give it a name so that I can delete it later on. I set its title and its content properties. These are data bound to those text boxes. I set the begin time to 15 seconds from now. For demo purposes, this is set to 15 seconds. Obviously, you'd probably do it longer than that. And in case you're wondering about the accuracy, the reminder service is only accurate to about a minute, right? So you can't implement an exact to the second reminder with this. It'll launch at the nearest minute. And then I set a navigation URI. And if you know about Windows Phone, you know we're all about navigation and passing URIs. And I passed in a URI to this page with the reminder content as a query parameter. And that means that when I get launched later on, I showed that contact to the red string that said hello from Build. And then I just add it to a thing called a scheduled action service. Not called a reminder service, but an action service, because we do other actions, not just reminders. We'll get to them in a bit. So that's all it takes to schedule a reminder, right? And then when I clicked on the reminder, we came back to the app, and I showed the hello from Build text in red. All I did there was I used our navigation context query string to pull out the value of that reminder parameter, right? So I set the reminder parameter, I pull it out, I set the data context, and then I delete the reminder if it's already there. So that's all it takes to schedule a reminder and then get context back into your app. So quick overview. Alarms and reminders on the phone, same UX as built-in calendar reminders. Provides a deep link back into your application. So anywhere in your app, you can launch to that specific item that's related to that reminder, just like with the calendar. And we have an efficient implementation based on the operating system, right? So you're not running some code in the background that polls every minute or does other things that could be using battery and could be using CPU, right? The operating system takes care of this for you. So the next thing I want to show is background transfer. Excuse me. And this demo may or may not work. It depends on how good the network connectivity is in here. So let's slide across to transfers. And what I have here is, oops, sorry. Let's switch to the correct video output. Here we go. So I have a page in the same, a pivot in the same app. And what I'm going to do is I'm going to click the download button. And what that is going to do is it's going to download a video from SkyDrive. And it's about 1 megabyte in size. And what you should see if I have networking connectivity is that there's a red bar that will grow to show download progress. But once that bar is started, I'm going to actually quit the app, right? But the transfer will continue in the background without my app running. Then we'll switch back to the application, and we'll see that the data was downloaded. So let's cross our fingers to see if it works. It often takes a few seconds for the service to come up. So you see it started. I'm going to quit the app very quickly. I can go ahead and do different things. But while that's downloading, so you don't have to wait, I'm going to show you the code. Then we'll come back, and we'll see that the thing actually downloaded. So let's go to the code for this one, background transfer. Again, no XAML, no UI. I'm just going to talk about code, but very, very simple. When I click download, start download, I'm going to create a thing called a background transfer request. It takes two URLs, the source and the destination. Now, they can be web to phone in a download, or they can be phone to web in an upload. So you can do both. I'm going to add a couple of event handlers for progress changed and transfer changed. The progress changed is what let me do the progress bar, so I could show if my app was in the foreground, I could show UI showing that progress is happening. And transfer status changed is just going to be things like there was an error, or it completed, or it's waiting for a Wi-Fi connection, or stuff like that. Then I add it to our background transfer service, and then I update my UI, which updates all my data binding. So that's it to load a background transfer. And then cancelling it, you might have seen there's a cancel button there. If I want to cancel it, I just remove it from the service. And that tells it to stop what you're doing, delete any temporary files, etc. So that's all it takes to initiate a background download, show some progress if you're in the foreground, and do with completion. So let's go back to the app and see if it finished while we were talking. So run the app again. And note this will be a new instance. I didn't even use fast app switching. I actually quit the app entirely. Go back to transfers, and you see it's done. It downloaded 902K. And if I click play, it's going to play just a simple 4-second video. Right? So that's downloaded in the background while my app wasn't running. So that's it for background transfer demo. Now I'll talk about some limits, because I said we balance UX and health. Right? Downloading lots of files could give you a great UX, but it also can really damage phone health. So we let you queue up to 5 transfers at once. And when those have done, you can queue 5 more, but you can do 5 things at once. And the kind of things that you can do depend on your network connectivity and your power state. So our network connectivity could either be a cell network or a Wi-Fi network. This is my awesome PM art. Or you could be on battery, or you could be on external power. Now, no matter what your network connection or no matter what your power state, you can always upload 5 megabytes with the transfer. And we chose that because that's about the size of a large image. So if you have an app that takes pictures and uploads them to services, you don't have to worry about the user quitting your app before your transfer is finished, because you can put it in the background transfer and we'll make sure it happens. So you can always send up 5 megs. Now when it comes to downloads, if you're using a cell network, we limit it to 20 megabytes. This is per transfer, so you've got 5 times 20, 100 meg. So 20 megabytes per transfer, which is the same rule we have for marketplace downloads. Right? If you try and download an app that's more than 20 megs, it won't work over cellular. If you have Wi-Fi and you're on battery, I apologize, these colors didn't come out too much, that says 100 megabytes. So you can download 100 megabytes of data, Wi-Fi and battery. Typically, Wi-Fi is free or much cheaper than cellular, so it's not eating into your cellular plan. And also, Wi-Fi is more power efficient than 3G, which is why we let you do more. And then finally, if you're doing a Wi-Fi download and you're on external power, there's no limit, right? Up to the limit of how much you can fit on the device. So you can download hundreds of megabytes if you want to in this state. So a quick overview of background transfer in general. It balances functionality with phone health and user cost, right? So we cap what you can do in battery mode. We cap what you can do with the data plan. It simplifies download management. If anyone's done downloads before, it's more than a couple of lines of code, right? You create a web request, you wait for it to finish, you create a byte buffer, you copy it from a buffer to a stream, you write it to disk. It's kind of messy, right? We do it for you. 2 URLs, source, destination, done. Uploads and downloads. Just like reminders, it's efficient. It's based on the operating system. So we do the power management, we do the network management, etc. And another really key thing is that our transfers persist across reboots. So say the user's on a plane, they're using your app, they start downloading a few things. The air attendants say, please turn off your devices. They turn off their phone, put it in their pocket. Plane lands, they pull the phone out of the pocket, the phone reboots, the downloads will then continue, right where they left off, right? So we even do this. So that's it for background transfers. Now I'm going to talk about live tiles. And we'll start with a demo. So my live tile demo is fairly lame. I apologize for that. Not very glitzy like everyone else's. What I have here is this is the app I've been running with my transfers and everything else. And I'm going to link to a couple of pages. I'm going to link to a blue page, which is blue. And I'm going to click this pin button down here. And what it does is it adds a secondary tile to the start menu. Now, you probably heard about this if you went to Jensen's talk or some other talks. And what this does is it gives me instant access to this particular page in my app. Right? I didn't have to start the app, navigate through some UI, click a button, get to this page. I can get straight into this page. If I do it again, let's say I want to click my link to my purple page. So here's what I have to do without a secondary tile. I launch it, I navigate across, I click on green. Finally, I'm at green. But if I click pin, it's right there on my start menu. Now, looking at these, they are kind of dead, right? They're just tiles that look just like my first tile. And they're not really doing anything. But we have live tiles, right? Not dead tiles, we have live tiles. And there are a bunch of ways that you can update live tiles. In Windows Phone 7, you can use our push notifications, so your cloud service can tell us to update tiles. But we can also do local updates now. So if I click this refresh button and go back home, we'll see that this green page will now flip over, and it will show that it's got some new green news. I have to wait a second for it to flip. And now it says latest green update here. Right? And I can do the same with blue. If I click on blue, and I click refresh, and I click back, we'll see that the blue page will also flip over. So if you have an app that isn't web connected but still wants a live tile and have this engaging experience on the start screen, you can do that now with our new live tile APIs. And I'll show you what that looks like in code. So let's go over to our... This time we're just going to look at app.xaml.cs, because I just have a couple of helper functions here. As you saw, the blue page and the green page were very simple. They just had an app bar with two buttons called pin and refresh. And what pin does is pin's a secondary tile. And it's very, very simple. I take in the title, which was green page or blue page, and I take in the URI, which was the URI of the page to launch, blue or green. I create an object called standard tile data, which represents the standard data that goes in a tile. I set its title to be the passed-in title. I set the background, in this case, to be the same background image that my primary tile uses, so that text that said build. And then I create a tile passing in the URI and the data. And that's it. Now I have a secondary tile. And you probably noticed when I clicked pin, we navigated you to the start menu and showed you right on the start menu where that tile went. And that does a couple of things. The first thing is it gives the user context, right? Here's exactly where my tile is, and if I want to reposition it to move it up, I can do that. The other thing it does is that it stops apps from spamming your start menu with tens or hundreds of tiles, right? The worst thing would be you start an app, you use it for a while, you hit home, and you've suddenly got like 100 of these things on your start menu that you weren't expecting. By navigating the user start, we make sure that at most an app can only do one at a time. And if you weren't expecting it, right from there you can go and uninstall the app and you never have to worry about this again, right? So keeping that delightful user experience and never regretting installing an app. Now updating it is similarly easy. And I could have done this when I created the tile. I could have set the back when I created it, but I choose not to. First thing I do here is I pass in again the URI of the page, the blue or the green page, the content on the back, so that was the blue news versus green news, and a new back image. In this case, it was a blue bitmap versus a green bitmap, but it could be anything. First thing I do is I try and find the tile from our active tiles. So if it hasn't been pinned, I'll just ignore this call and I will do nothing. But if it's been pinned, I will find it. Then I use my standard tile data class again, add a couple of new properties, the back content, which is the text, and the background image, which is the background image. Then I update the tile, right? And that's all it takes to do local API-based tile updates. Very simple code. So if we look at the overview, things new in Mango versus 7, you can pin multiple tiles to start. Great for shortcuts into your app. There's a new flip animation we have with additional content, so your tiles can actually be live. Even if you're not using push notifications, you can have a live tile that flips around and shows data. And there are 3 ways to update them. Right? I didn't talk about push or schedule. They are same as they were in Windows Phone 7, except that they can now target multiple tiles. And frankly, I don't have time to talk about them. And a new local API that lets you update tiles if you don't have a cloud-based service. So now it's time to actually start running code in the background. Right? Up until now, you've seen a system service to do transfers, a system service to do reminders, and a local API to use tile updates to make it look like your app is alive. Now let's talk about actually running code. So I'll run my app again. go across live tiles, and now to agents. Oops, already running. Demo fail. You practice too many times and you forget to undo the practice. So here I am on the agents page, and you'll see there's a button here that says Start Agent. And an agent is our term for code that you write that runs in the background. And we'll talk a lot about that, what that means after the demo. So you've seen my tile. I had the blue tile flipping with data, and I had the green tile flipping with data, but they only flipped when I went into the app and I clicked that refresh button, right? What if I want my tile to be live and update all the time, but I don't have a back-end service that can push? Right? You can actually still do that. What I'm going to do here is I'm going to click Start Agent, which is going to start a background agent. You'll see it now says last scheduled time, 12 a.m., because it hasn't run yet, and last exit reason, none, because it hasn't run yet. Now, if I go to my Start menu, excuse me, we'll watch this build demo tile here, this one, not the blue or the green, but the other one. It'll flip over. Now it says Cliffs of Dover, which is a picture from Dover. And if we wait a few seconds, now it says Castle at Night. It's now a picture of a castle at night. And if we wait a few more seconds, it'll flip again. And then it will flip over and it will show me a new image. You don't control the rate at which the tiles flip. The operating system does that. So now it's a glass of wine. Right? So we're seeing that my tile is updating in the background with new images constantly. So how do we do that? Well, before I look at the code, let's have a little look at a high-level architecture, and then we'll look at the code after that. So having these agents run requires three things. It requires you, the developer, it requires the operating system, and it requires the application code itself. Now, if we look at how a traditional Windows Phone app works, you have a foreground application that has some UX in it, and it has some logic in it. And it can talk to web services, it can talk to its isolated storage, and it can talk to system services, like the shell, for example. In the case of live tiles, you're talking to the shell to ask it to display content. What background agents do is that they say, take some of that code, move it into a separate assembly, move it into a separate process, and it can talk to the cloud, it can talk to the isolated storage, it can talk to system services, but we can run it in a separate process independent of your UI, which means even when you're not in the foreground, you can have code running. And it's a process that has less memory and it has less CPU, because we want to balance the phone health of foreground and background, but it is a process that runs your code. And from the operating system's point of view, your foreground and your background process are still the same app. Right? So they get installed together from the marketplace, they get uninstalled together, they have access to the same isolated storage, the same security context. So for the OS, it's just an app. To you, it's two processes, foreground and background. So how do you do that as a developer? Well, if you've ever done any multi-project development before, like Silverlight website on an ASP, Silverlight controller on an ASP.NET website, right? Same basic thing. You write a solution, you write a project that is your foreground, same as you always did. You add another project, which is your background logic. You can reference that in your foreground application if you want to reuse code. And then we tie them together with our app manifest. So the manifest in your application says, here's the assembly to load when you want to run a background agent. So that's the high-level architecture. Let's look at the code. So when I call start agent, which starts my background agent, the first thing I do is I create a periodic task. I could have created what's called a resource-intensive task. I'll talk about that in a minute. But I create a periodic task, which means it runs periodically. And I give it a name so that I can find it later and I can manage it, etc. I give it a description, updates the demo app tile. If I have time, I will show you why I need that in a second. It essentially appears in our control panel UI so the user can manage it. The next thing I do is I add it to our scheduled action service. So remember I said when I added my reminder, I didn't add it to a reminder service, I added it to an action service, because an agent is another kind of action that we can schedule. And then I use this sneaky developer API called Launch for Test, so it runs instantly, so I can demo to you without waiting a long time. And I put this inside a try-catch block because the user can actually disable agents if they don't want your agent to run. A great example of this is, say you have a location-based app, and it periodically gets your location, uploads it to a web service so people can find you. But let's say you don't want people to know where you are for a while, right? You're off on some secret trip somewhere. Rather than having to find out the app and find out how to turn it off in the app, you can go to the central control panel and just disable that agent to say, I don't want this agent to run while I'm off doing my secret thing. And then the next time I start the app, I'll start the agent again. So that's why we put this inside an exception handler. And then I update my UI, which just changes the button from start to stop. Then stopping the agent is very easy. Just like with the reminder, I tried to find it, and if I found it, I remove it. Same thing with the agent. I try and find it. If I can find it, I can remove it. And I'll quickly show you the cancel UI, actually, just because I'll talk about it. So if I go in here, run my app, let's stop the agent for now. Let's hit start. Let's go to settings, flip across to background tasks. And you'll see that there are a bunch of things in here. Flickr and World Time are some samples that we have internally. Build Demo App is the one I'm using, and Tweet Agent is that other app I showed you with the multitasking. So if I go to Build Demo App, it's currently turned off because I turned it off in the foreground. And there's a checkbox here that says, allow the app to run this thing again. Now if I uncheck that, and I task switch back to my application, and I click Start Agent, that's when the exception handler kicked in. It said, I couldn't do this. And basically, the only thing you can tell the user is, please go to Control Panel to re-enable the agent. Right? Doesn't make sense if we had an API for you to programmatically launch your agent again. It has to be a user action to enable the agent. So let's click OK. Let me go ahead, switch back. Click this box that says, it's OK. The app can turn this agent back on again. Switch back over here. Agents, Start Agent, and now it's running again. Right? So the user is in control of when the agent runs or not. Now, what if I've showed you what it looks like to start and stop the agent in code? I said that there was a link in our manifest that tells us where to find this background agent. So if you look here, we have this extended task. So our default task is our main navigation page for our UI. Then we have a background task. We have which is new in Mango, specify a scheduled task agent, which means this is a task that runs on a schedule. Schedule, for some of you. Its source is simple tile updater, which is the name of my project, if you can see off the screen here. And the type to run is simple tile updater.scheduleAgent. Right? That's the class to run whenever this agent needs to run. So let's look at what it does. It's a very, very basic piece of code. It derives from this class scheduled task agent, which is the base class you need to derive from to build an agent. It lives in its own assembly. And it was doing something basic, right? It was just flipping between a bunch of random images. So I have an array of strings for the file names, and I have an array of strings for the descriptions. And then I override this method called onInvoke. And this is the method that gets called whenever we want your agent to run. And it's just standard, C# code, right? I create a random number. I look into my file name and my description from that random number. I use the same tile data, standard tile data class I was using in my previous example to update the background image and the background content. I could also update the foreground if I wanted to. I find my first tile. Now, the first tile is always your primary tile. Whether it's pinned or not, you always have at least one tile, which is your primary tile. And I update it with the tile data, right? And that's why you saw the tile changing the background. And then again, here's that magic launch for test API that I called so that you don't have to wait for the operating system to schedule me again. This works for dev apps on dev unlocked phones. Works in both debug and retail mode, so you don't have to have the debugger attached. You can launch your agent as often as you want, including every second. But it will know up on a retail device with a retail app. Right? So this isn't a way for you to run code constantly in a real app, but it's a great way for testing application agents. And then finally, I call this important method called notify complete. And what notify complete does is it tells the operating system, I'm done servicing this invocation. Now you can shut me down. Right? Managed constrained processes, balancing health with UX. we do need you to tell us when you're done. If you don't tell us you're done, we'll kill you in 25 seconds anyway. And if you do it twice in a row, we'll kill you permanently. So it's in your best interest to call this. But if you end within 100 milliseconds or 20 seconds, we won't know unless you tell us. Right? So there's a fail-safe, but you should always tell us when you're done so we can kill you as soon as possible, give battery back to the user. And that's basically the code for writing an agent. So what can you do in an agent? Pretty much what... Oh, sorry, question.
If you go back, how often is your process being invoked?
Question is how often? I'll get to that in a couple of slides. Okay. So what can you do in an agent? Pretty much anything you expect to do if you don't have a UI, and nothing you don't expect to do if you don't have a UI. So I can do things like tile updates, which I've showed you. I can show toasts. I can pop toasts if there's new messages, for example. I can do location-based services. I can do networking and storage and all these kind of cool things. What I can't do, though, is I can't use sensors. I can't use the microphone or the camera, right, because that would be kind of intrusive to the user's privacy. I can't use graphics or audio because I'm not in the foreground. And I can't use anything from XNA because XNA is really all about graphics and sound. So it basically makes sense, right? Process with no UI, what can you do? Well, things that don't require UI. And there are two flavors of agents. Remember I said I created a periodic agent, but I could also create a resource-intensive agent. Here's the differences, and here's the answer to your question about how often it runs. So a periodic agent, if you're not using that launch for test API, which cheats, runs every 30 minutes, as long as the battery level is above 20% and the user hasn't turned on battery saver mode. Right? So when the battery gets low or the user tells us, I want to preserve battery, we automatically suspend these things. But they run every 30 minutes. Resource-intensive tasks, on the other hand, run when the phone is plugged into external power and the battery level is above 90%. Right? And you'll see this resource-intensive agent, we also kind of call it nightstand mode at Microsoft, because it's like I go home at night, I plug my phone in, I go to bed, and it's doing nothing for 6 hours or 10 hours or however long you like to sleep. Why don't we do some work while we've got all those resources? So the next difference between them is what kind of networking they can do. Now, a periodic agent can use your cell network, and we'll get to why that is in a second. So it can do data if I'm out and about. I'm here at Build. I can use my cell account to do some downloads. The resource-intensive agent, on the other hand, is forced to use a non-cell network. Right? So typically Wi-Fi, or if it's plugged into your computer, it can use desktop pass-through to use your computer's network connection. So it essentially has no limits. Just like with the background transfer service, there's no limits for a resource-intensive agent. Now, a periodic agent, as I mentioned, runs for a maximum of 25 seconds. Typically, they run much faster than that, but this allows you to have, say, some network lag if you're calling into a web service. But a resource-intensive agent runs for 10 minutes in a recurring round-robin fashion. So if you have, say, 5 resource-intensive agents on your phone, you put the phone on the nightstand, you go to sleep. We'll run them all for 10 minutes, and then if they still have more work to do, we'll start again, and we'll run them all again for another 10 minutes. Right? So we kind of all give them a slice of time, and we give them more time if they need it. And we do that until the phone wakes up. And the kind of scenarios that we have are that periodic agents are used for things like tracking your location, getting simple data syncing, pulling things from RSS feeds or Twitter, etc. And the resource-intensive agents are for bigger, bulkier tasks, right? Like doing a large data sync or like end-of-day processing if you're doing more of a business-type application. Right? So this one, nightstand mode, resource-intensive, all the power it wants, all the network it wants, for as long as it wants in 10-minute chunks. The periodic one runs fairly frequently, any network, only 25 seconds, and it can only do a small amount of work. So they're the difference between the two. And an overview on background agents. This is a separate resource-constrained process. So same application to the OS, but a separate process, less memory, less CPU. Managed by us to maintain phone health. So we just looked at how we manage these things. We run them every half hour for 25 seconds, or we run them when you're not using the phone and it's plugged in. I've shown you how the user can stay in control using settings. So again, even if you you install an app and you only ever run it once and you don't like it, the user can turn off the agents, and we have another feature that I didn't mention, which is if you don't run an app for 2 weeks, but it's scheduled an agent, we'll also kill the agent then. The assumption being, if you haven't run the app for 2 weeks, you probably don't want the app and you forgot about it. You just didn't get around to uninstalling it yet. And so these things won't run forever. And it's a familiar .NET programming model, right? There's nothing special for multitasking. It's just a C# class with a method that I override, and I go and do my stuff. Right? No UI, but I just do normal C#. So let's look at background audio, which is the last of our services. And for this one, I'll actually be running it on my laptop because I need, I'm getting sound coming out of here, and I have some media on my local laptop. So it's not that it doesn't run on the phone, it's just that for demo purposes, I need it on my laptop. So this is my audio demo. I'm going to run it in the emulator. And here we have my LCA-approved media player. It says it's going to play Pet Shop Boys, but it's not. I can't play Pet Shop Boys. I don't have the rights to play Pet Shop Boys. So we are going to play some music that we have licensed. Please don't judge me on the music. If you like the music, great. If you don't like the music, I apologize. But this is like any average media player, right? I'm going to click play. And assuming that we have audio, yep, we have audio. So you can hear the music is playing, right? Nothing fantastic about that. You can do that in Windows Phone 7. And I can do things like I have a progress bar here showing me how far I am in the track. I can skip to another track with a skip button. Nothing fantastic there. But what if I quit the app? Right? App's gone. Music keeps playing. Right? This is the new thing in Mango. We now have background audio playback. And not only that, but if I use the system UI, so for those of you that don't know, in the emulator, F9 and F10 are the volume keys. They'll bring up what we call the UVC, the Universal Volume Control. And you'll see here that I'm playing with the volume so it doesn't disappear, so I apologize for the 2021. I have the track name that came from my app. I can pause and it pauses. I can play. I can skip, so it skips to another track. If I run my app again, right, you'll see it's now got the updated album art. The music's a little low, but it's playing. And you'll also notice if I go here and I run this again, and I skip again, you'll notice that this is now grayed out. I can't skip anymore. And that's because, and this one's loud, sorry, let me pause. And that's because my particular application has a piece of business logic that says you can only skip 3 tracks, right? And then maybe you have to listen to an ad, or maybe you have to wait an hour or something else, right? So a lot of services have these rules that some tracks you can skip, some you can't. Sometimes you can only do so many skips per hour or per session or per station. So we can build that kind of logic into our app and still have it reflected in the system UI. And one other thing I'll quickly show you is if I go to Internet Explorer and I go to IE test, page up, page down, allows you to use the hardware keyboard on your laptop if you didn't know that. If I go to ietestdrive.com/mobile, I click on HTML5 Demo's audio player. You'll notice this is suspiciously the same licensed music I was playing. So we're playing music. Oops, that shouldn't have done that. Let's go to another track. I switch away from IE. I can pause. I can play. I can't skip from the UVC. But if I go back to IE, here I am, I can skip. Sorry, this is loud. Right, so even our browser can do background audio playback with HTML5 audio. So that's something that no one else does. So let's take a look at the architecture here again before we look at the code. And it should look very, very familiar. Just like we talked about background agents before, I have my UI. It talks to my cloud to get my music, and it talks to my ISO store to get settings and so on. And of course, it talks to Zune to do the playback. Right? This is essentially the same diagram I had in the previous slide. Zune then talks to our universal volume control, which is where the play, pause buttons, etc. come from. Which is all great if you're in the foreground, and this is how we could work in Windows Phone 7. But what happens when your application goes away, right? And then the user clicks skip on the UVC. We need to know what to do because we're not the ones that write the music service. You're the ones that write the music service. So we have a background agent, right? And the background agent contains the logic to say, here's how many tracks you can skip, here's how I get the track from the web service, here's how I get the metadata, all that kind of stuff. So it's built into your background agent. And of course, your foreground app can come and go, right? Come and go as the user switches in and out, into and out of it. But because your playback needs to be continuous and happen all the time, all your logic now lives in the background agent, right? So your UI ends up just being like the view model in the view, and the model goes into your background agent, right? So your UI shows the metadata of the current tracks that you're playing. It controls playback with the pause and fast forward buttons and so on, but it doesn't contain any logic about what my playlist is, how do I skip, all that kind of stuff. That's all living in the background agent so that we can always run your code even if you're not in the foreground. So let's look at that code. And we will look, well, this is the stuff I'm running. So I just have a simple XML file. This is why I had to use my laptop because it's getting content off my local web server. This is just my sample XML playlist, right? Music services have their own way of doing this. They'll have their own format, their own data types. I'm just using this sample third-party track info just to show that Zune isn't the one that decides what format to use, right? You as developers decide what format to use. So this is the playlist that I play. Now in my app, this is my foreground app, setting up the player is really easy. I get the single instance of the background audio player. It's a singleton. You can only have one thing playing audio in the background at once. And I listen to the play state changed event, right? Remember I said you're just essentially showing changes in the metadata and then driving changes into the model. The model will live somewhere else. My play state changed handler, which obviously gets called when I pause or skip or whatever, is very simple. If my play state is playing, I'm going to grab the latest track out of the background audio player. I'm going to update my track metadata, which is just a bunch of data binding to that image and the text and so on. And then I'm going to set a flag, which I just use internally, which isn't really relevant to this discussion. Then I update my UI, right? And this basically says that the app bar button goes from being a triangle to being two rectangles, right? This is the updating the UI. So I'm responding to events, and then I have two handlers for the app bar buttons. I have a play pause toggle, so if I'm playing, I pause, and if I'm paused, I play. And when I want to click the skip button, I call skip next, right? And that's it. Everything else in this thing is just data binding logic, right? So nothing about reading XML playlists, nothing about how to skip 3 times, nothing about that. It's all just data bind when I get an event, and then tell the player to pause when I click on the UI. So let's look at how the agent works. And I'm not going to spend too much time on the code here because I want to get in a bit of a debug demo just to show how it works. But just like my generic agent had an onInvoke call that I got called and I could do some work, I have 2 basic callbacks for my audio agent. So I'm deriving from audio player agent instead of scheduled task agent. And there's 2 overrides. One is on user action, and that's things like the user hit pause, or the user hit play, or the user hit skip. Right? Either from the app itself calling those APIs, or from the system UI, right? That UVC where I could call play, pause, etc. And all this really does is, if the user asks to play, I'm going to play. If the user asks to pause, I'm going to pause. And if the user asks to skip, I'm going to check if they had any remaining, right? This is my business logic. And as long as they do, I'm going to decrement those number of skips, and I'm going to play the next track, right? So very simple. This is where my logic about, is the user allowed to pause? Is the user allowed to skip? That's where this happens. Now, this doesn't define the UI, whether the UI is enabled or not. We'll get to that in a second. But this is what determines whether or not the user's requested action can actually be carried out by the system. So the next thing is on play state changed. This is another callback that we call whenever the playback state of the system changes, right? Very similar to current state changed in media element, for example. And if the play state is track ready, meaning the track's loaded and it's ready to go, I just call play. If the track has ended, I play the next one, so I can keep going down my playlist. And actually, in both cases, I call that notify complete method. Remember I talked about you have to tell us as soon as possible when you're done so that we can suspend you or put you to sleep. It's important in audio agents too to also tell you when you are done. And then play next track, which is my helper function, basically just gets the next index into my, I've created that XML playlist into an object model. I just find the next one in that list. Here's where I check for the disabling of that button in the UI. I always enable pause, but I only enable the skip next control if they have some skips remaining. Right? So as soon as that hits 0, we disabled that button in the UI so that the user couldn't click it. Then I create an audio track, which is the track that we understand based off the metadata that you have, right? My sample third-party data, your metadata could be whatever you want. I create a track based on that, and then I just set the track to be what it was. Right? Zune will pick up that track, it'll do some parsing logic, etc. It'll raise the track ready changed event. I'll call play, my music starts playing. So this is the simple way of doing things. It's what we call track-based playback, because I have this simple list of tracks and they're all standard MP3s. We have a more complicated method, what we call buffer-based playback or media stream source, if anyone's familiar with media stream source. I won't show that today because it's long and complicated, but if you don't have standard MP3s or WMAs, let's say you have an encrypted stream, or you're using a shoutcast stream, or you have some other kind of data that isn't standard Zune format, you can actually do the parsing and the decoding yourself and hand us audio buffers over and over again. But I won't get into that today. I'll do a very quick debugging demo just to show you how this works. So let's go to on user action. So this is in my background agent code. I'm going to check for when a call comes into a user action. And in my foreground app, let's just put a breakpoint on play. So I'm going to hit F5. And this will work the same as any multi-process debugging in Visual Studio, right? If you've done ASP.NET with Silverlight, or WPF with a web service or anything like that, it's all going to be the same thing. So here I am in my app. I click play. And you'll see here, hopefully, it says UI task. If you can't see this, I apologize, but it says UI task, meaning I'm currently debugging the UI task process. And I'm going to call play. So hit F5. We're back in the debugger, and now it says background task, right? Two processes, UI task and background task. And I apologize for the small text. And here I am inside my on-user action, because the user asked me to play. I'm going to play. And actually what I'm going to do, I'm going to put a breakpoint on play state change as well for track ready. So I'm going to play next track, which is going to look at that XML file, find the next one, set the track, hit F5. Now my play state change handler came in. It says, Zune found that track. It's now ready to play it. Hit F5. Now I get a bunch of other callbacks too, like buffering and so on. And now it's playing, but I think the AV people have turned off the volume. But you can see it's playing. So that's it for background audio, and I have a couple of minutes just to finish my slides. So, sorry, I don't need it anymore, but thank you. Let me pause that. So you saw HTML5 audio in Internet Explorer playing in the background, really cool feature. I showed you track-based playback for standard Zune formats like MP3 and WMA. I talked about, but didn't have time to show you, our buffer-based playback for other formats. And one thing that's really, really cool, because we use this agent mechanism where it's a separate process, it's constrained memory, it's constrained CPU, we actually guarantee you those resources. So on other platforms, if you start media playback, And then you start a bunch of apps, maybe some games that use a lot of memory. Over time, they'll fill up memory, and eventually your audio will get kicked out. And you'll be listening to a song, and all of a sudden the song will stop. And you don't know why. And it's because they had to kill that process to get back the memory. In Windows Phone, what we do is we reserve that chunk of memory and the CPU reservation for that agent, and we make sure that no one can take it from you. So if you start playing audio, it never stops, right? Until you stop or the user plays some more audio. Right? We never kick you out just because someone else allocates a whole bunch of memory. So recap, this is my first slide. Broad set of features, transfers, reminders, agents, audio, fast switching. We talked a lot about balancing what you do as developers and what you can give as user experience with what the phone needs to do to maintain health. And it's all familiar .NET stuff. There's no magic, there's nothing new to learn. It's just .NET code. So that's a picture that you should keep in your mind as you're developing apps. And thank you all for coming. Please fill out the questionnaires, the session feedback. Very valuable for us to help make these events better, help us get better. And I'm out of time, but if you want to ask questions, I'll be here and I can be outside too. So thank you for coming.